In the last video, we showed that the set of left cosets of NZ inside Z under its addition and multiplication is a ring. Now, in this particular video, I want to make a note that I know that Z itself is a commutative ring with a multiplicative identity. And it turns out that because Z is a commutative ring with a multiplicative identity, that the quotient ring is also going to be a commutative ring with identity. So we're simply going to kind of state that right now. I want to show that the quotient ring, the set of left cosets, under its addition and multiplication, is also a commutative ring with a multiplicative identity element. Now, it turns out this is not very difficult, and again, you should try and do this on your own. So the very first thing is I want to think about showing that the quotient ring, Z mod NZ, is a commutative ring. So stop the video and try and prove this for yourself, and then compare your proof to mine. So hopefully you did that. Here's my proof. We're going to let A plus NZ and B plus NZ be two elements of Z mod NZ, the set of left cosets of NZ inside the ring Z. And what I want to notice is that we can look at this idea. A times NZ, rather A plus NZ times B plus NZ. By the definition of coset multiplication, that's just AB plus NZ. And of course, this element here is inside Z, and I know that AB is equal to BA inside Z, so I can write that as BA plus NZ, since AB equals BA inside the ring Z. In other words, because Z itself is a commutative ring. And then finally, I just use the definition of coset multiplication again, and that's going to be B plus N times Z times the coset A plus N times Z. And again, that is by the definition of coset multiplication. And hence, Z mod NZ is indeed a commutative ring. Now, finding a multiplicative identity is not very hard either. So I'm now going to say that I'd like to show that Z mod NZ has a multiplicative identity element. So again, stop the video, see if you can find one, and prove that it is indeed a multiplicative identity. Hopefully you did that. Here's my proof. Consider this coset. 1 plus N times Z. 1, of course, is a perfectly good integer, and 1 happens to be the multiplicative identity inside the integers. So this particular thing is indeed a left coset. So he belongs to Z mod NZ. Now look at this. If I look at 1 plus NZ and I multiply by A plus NZ, by the definition of coset multiplication, that's just going to be 1 times A plus NZ. But I know that this element lies inside Z, and 1 times A is just going to be equal to A inside Z. In other words, I am using the fact that Z has a multiplicative identity element here. And obviously, the multiplication works the same going the other way. This is also going to be A plus N times Z. And hence, 1 plus N times Z is the multiplicative identity element of our quotient ring Z mod NZ. And that completes this video.